So then I've been asked to show a little bit what we did with mathematical models on African swine fever. So I don't think I need to remind you what African swine fever is. It's everywhere in Eurasia. Not yet in France, but maybe soon. The question is not if it will arrive in France, but just when, I think. So of course it's a disease of high interest. So I will illustrate how we use mathematical models to try to better understand the epidemiology of ASF in different settings, including a setting in South Korea, where which is work that was part of Junchik's PhD that is successfully defended 2 weeks ago. So the first application is work that was done during Brandon Hayes' PhD. We wanted to understand the importance of transmission routes for ASF in Romania. And most importantly, we wanted to understand what was the role of the wild boar versus the domestic pigs in the spread and maintenance of the virus in Romania. So in Romania, the virus emerged in 2019. And then there was a big epidemic, and it's kind of endemic now in Romania in both domestic pigs and wild boar. So in this figure, you can see the incidence in domestic pigs, which is the red histogram, and in wild boar, which is the yellow histogram. And then the question was for the domestic pigs, for the domestic pig farms, what was the likelihood that the infection was coming from another domestic pig farm or from wild boar habitat? And then we had the same question for the wild boar habitat. A wild boar habitat, was it more likely to become infected by a neighboring wild boar habitat or by a domestic pig farm located within this habitat? So to do this, we used a multi-host mechanistic model of ASF transmission with domestic pig farms as unit and wild boar habitats as other types of unit. And there could be transmission in all the different directions. And by fitting this model to the epidemic data from the early stage in Romania, the authors could estimate the relative frequency of disease introduction from different sources. And basically, this graph should be read as follows. So for example, in this one, that shows that domestic pig farms, where most of the time they were infected through direct or indirect contact with other domestic pig farms. Okay, so domestic pig farm to domestic pig farms accounted for almost 75% of the virus introduction within pig farms. And that the introduction from wild boar accounted for less than 20% of the infections in domestic pig farms. And we did the same for wild boar. And basically what was shown is that wild boar habitat in 75% of the cases was infected because the neighboring wild boar habitat was infected and the virus spread to that new habitat. So in the end, the infection, the transmission of ASF virus within Romania was most likely to be within the compartment, within domestic pig compartment and within the wild boar compartment. Then we had a question that was asked by the EFSA. It was to investigate the impact of wild boar density. So the question was whether the wild boar density impacted the way ASF virus spread within a territory. So basically for this one, we went to the Italian context in northern Italy, where there was a huge epidemic starting in 2020. We got the distribution of the estimated wild boar density in that region. And we also got the spatio-temporal distribution of the wild boar cases that were found in this region. And so we tried to combine the wild boar density map with the spatio-temporal distribution of the outbreaks within a mechanistic model. So we managed to fit the model to the epidemic data. So the observed data are the dashed line here. The green envelopes are the prediction from the models. And the blue line here represent the true epidemic, because obviously the epidemic is biased because of the surveillance efforts. And so we accounted for the surveillance effort to to reproduce the observed epidemic. But by doing this, we could reconstruct the true epidemic, okay? So which was shifted by a few weeks before. So that's the true incidence in blue. And what we found in this case study is that there was no wild boar density effect across the entire study period. From week 0, we looked at 2 waves. So from week 0 to almost 2 years later, there was no constant wild boar effect across the study period. However, during the second wave, we showed that the epidemic was more likely to go in the direction of high density areas than towards low density areas. So in the end, we showed there was no wild boar density effect across the entire study period, but that there was a wave specific effect with wild boar density having shaped ASF spread during the second wave. So that was something that was kind of striking, that it was not possible to show an effect, a constant effect. If there was an effect, that was a bit weird. And then finally, I'm coming to the context of Junshik's PhD, where the question was to one of the questions was to estimate the impact of wild boar habitat on ASF spread. And so for this, Junshik used sorry, not HPAI, but African swine fever data from 2019 to 2022. Again, it was based on Brandon's model. So it was development of Brandon's model. So it was a space-time mechanistic model. I will not go into the detail, but the model was fitted to the observed data, spatially and temporally. And that could estimate the impact of wild boar habitat. And in that situation, the effect was much more clear than in Italy. So in here, what was shown is that the susceptibility of the wild boar habitat was highly dependent on the forest coverage, so on the wild boar habitat suitability, with wild boar habitat patches with a high forest coverage, so with a high wild boar habitat suitability, being much more susceptible than the forest, I mean the habitat patches with low forest coverage. So much higher susceptibility and also a much higher infectivity. Okay, so it should remind you a little bit what was done on HPAI with the duck farms and the chicken farms. So it's much more susceptible and much more infectious. And by projecting these parameters to the South Korean peninsula, there was this clear pattern towards the Sobek and Tabek mountain ranges in the east, with high values for the so this map represents the distribution of the basic reproduction number at the cell level, and so it showed that the highest values for the R0 would be very congruent with the distribution of the mountain ranges. So with what Junshik loved to say, it's the concept of high east, low west, even for the R0. And also what was shown using this mechanistic model is that on average, the true wave front, so the true cases that were not yet detected, was usually between 20 or 30 kilometers more south than what was already observed. If we ignore the long distance transmission events, just the wild boar spread, there is a discrepancy between the observed wavefront and the true wavefront by between 20 and 30 kilometers. Okay, so takeaway messages from African swine fever. So the mathematical models have contributed to estimate different things. So in Romania, it was shown that most transmission events occurred within the same compartment without too many transmission events between the different compartments. We could use mathematical models to understand that in northern Italy, wild boar density effect was not so clear. Okay, there was not constant effect, but maybe a wave-specific effect. However, in South Korea, there was a clear impact of wild boar habitat suitability. And so all this taken together tells us that to understand wild boar spread patterns, we really need to work accounting for local context. Okay, it doesn't seem to be a general law about African swine fever transmission because of the very different production systems and ecological drivers in the different countries. So the perspectives is that we want to model ASF spread. We want to apply these models to different contexts of different wild boar density to try to better characterize the effect of wild boar density. And then we want to use these models to integrate different management strategies like the fencing, for example, or the depopulation in order to optimize their implementation and to estimate their